All right, 8A, we're going to look at the process called hypothesis testing. And to do this, we're going to use as an example our activity from last class where Coach Rivers said he was an 80% free throw shooter. We had him go take 50 free throws and he made 32. So 32 out of 50 is only 64%. And we want to know if he is exaggerating. Okay. Mathematically, the question we're asking is there statistically significant evidence that Coach Rivers is exaggerating his ability? Okay, so in our activity, we did a simulation with a dot plot to try and get some mathematical evidence. Okay, today we're going to learn the official statistical process for this, which is called a hypothesis testing. So when we do hypothesis testing, we have two hypotheses. Okay, and this is like our two, just like we did our two explanations. Okay, the official term for them is hypotheses. So we have a null hypothesis. Okay, and that is our default belief. The null hypothesis is always assumed to be true, and the null hypothesis must have an equal sign. Right? Then we have our alternative hypothesis, which is the belief that we are trying to test. So we're trying to see if our sample data can prove that the alternative hypothesis is true. Okay? When we talk about how this works, it is very similar to the way the court system works. So in the United States, you are considered innocent until proven guilty. Right? So we assume that you are innocent and they must provide evidence to prove you are guilty. Okay, so the null hypothesis would be that you are innocent. We're going to assume innocence unless we have convincing evidence that you're guilty. Okay, and that's why when they give the verdict in court cases, they either say guilty or not guilty. They don't say the person is innocent because it's not your job to prove that you are innocent. That is assumed. So it's not our job to prove the null hypothesis. It is already assumed. So what are our hypotheses in this situation? For our null hypothesis, we're going to give Coach Rivers the benefit of the doubt and assume that he is an 80% free throw shooter. But then we're going to see if our sample data is enough evidence that he is less than an 80% free throw shooter. Okay, so we need to be able to write these mathematically. All right, so when you write hypotheses, we have null and alternative. We are talking about, in this case, a proportion or percentage of free throws that he makes. So we're going to write it as P equals. So my null is always equal, so P equals 0.8. And then my alternative is that he is less than an 80% free throw shooter, so we think that P might be less than 0.8. And the question that we are trying to answer is, how unlikely is it that an 80% free throw shooter would only make 64%? Okay, how unlikely is it? And if it's too unlikely, we do what's called reject the null hypothesis, which means prove that we have evidence for our alternative. Okay, so what we saw in our activity is we did our dot plot, and the probability that an 80% free throw shooter would only make 32 out of 50 was super small. And so we decided that Coach Rivers was not an 80% free throw shooter because the probability of our sample happening was so small. Okay, so here's sort of a generalized process. We're going to do the actual details in the calculator in the next lesson. But what you need to understand, we assume the null hypothesis is true. We're going to collect sample data, which is what we did last class where we had 32 out of 50. And then we're going to calculate how unlikely our sample data is. So that's why we did that whole thing with the little simulated shooter and the dot plot. We wanted to know what are the chances of an 80% free throw shooter only making 32 out of 50. All right. And then if that probability is low enough, we can do what's called reject the null hypothesis. And if it's not low, if it's not super low, we'll be like, oh, okay, that just happened to be a bad day. We fail to reject the null. Okay, same thing we talked about with the court. It's either reject or fail to reject. We never say we accept. Okay, so in statistics, the opposite of reject is fail to reject. We are never, ever, ever going to say that we accept the null hypothesis. Just like in court, they're never, ever, ever going to say that you're innocent. They're going to say you're not guilty. Now, in the testing process, it's possible to make an error, all right? It's possible for our probability to, we're not talking about a mathematical error here. We're talking about like our probabilities being off or, getting that just super weird sample, okay? And so we classify these errors into two types. A type 1 error is we reject the null hypothesis, but it's actually true. And then a type 2 error is we fail to reject the null hypothesis, but it's actually false. Okay, so let's look at this example. The limit for salmonella in chicken is 20%. A meat inspector believes the chicken produced by a company exceeds that limit. So when will a type 1 or type 2 error occur, and which one is more serious? So to do that, we need to know what our hypotheses are. Okay, so I have my null hypothesis and my alternative hypothesis. Okay, the limit for salmonella is 20%. So my null is going to be that P is equal to 0.20, which is 20%. And then the meat inspector believes that the company exceeds that limit. So my alternative is going to be that P is greater than 0.20. Okay, so if I make a type 1 error, right, then that means I have rejected the null hypothesis. Okay, so in my mind, I believe that the alternative, is true. So when we define errors, we're going to say, we conclude. What is our conclusion? So if I make a type 1 error, that means I have rejected the null hypothesis. So I conclude that the chicken exceeds the limit. Okay, because I rejected the null, so that means I think this one is true, and this hypothesis says that it's greater than 20%. So we conclude the chicken exceeds the limit, but really, okay, because remember we made an error, really the null is true, so really it is safe. Right? That is what a type 1 error would look like in this situation. Okay, now if I make a type 2 error, what does that mean? Right? If I make a type 2 error, I fail to reject the null, which means I think the null is true. All right, which means I would conclude the chicken is safe. Okay, but just like before, I made an error. So, but really, what? Really, the alternative is true. So really, it exceeds the limit. Okay. All right, so when you are writing conclusions, I need to know what you conclude and then what is really the truth. Okay, so this part will be dependent on the situation, right? But you're always going to write like we conclude blank, but really blank. Okay, now which one is more serious? That is always dependent on the situation. That's why we like to write out what the both errors would look like, and then let's decide which one of these would be worse. All right, we conclude the chicken exceeds the limit, but really it is safe. So if we conclude that the chicken exceeds the limit, what are we going to do? We're going to recall that chicken so that it doesn't get sold to make people sick, which means the company is going to lose money, and they probably have to like really super clean the factory when it's not necessary. Okay, so they would lose some money here. Okay, but in a type 2 error, we conclude the chicken is safe, but really it exceeds the limit. In that case, we would think this chicken is safe, and people would be buying and eating chicken that has salmonella. That's not good. So in this particular case, a type 2 error would be more serious. Okay, but it always depends on the situation, so you have to read what both types of errors would be. All right, so now our question, is Coach Rivers really an 80% free throw shooter? We'll answer that in 8B.